Okay, question 21. The photograph shows a sequence of pictures of a man jumping 30 metres from a cliff into the water below. Ignore the first picture and consider the second picture representing the instant he jumps. Ignore the final picture, the splash, taking the 10th picture and showing the time when he has fallen 30 metres. So first of all, I'm going to number these pictures. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's telling us to ignore that first picture. That's important. The diagram shows the 10th picture of the man. It is useful to mark the centre of the gravity for the man in each picture before taking measurements to analyse the motion. State what is meant by centre of gravity and mark its approximate position on the diagram. So the centre of gravity, you should have just learnt, is the centre of gravity is the point where weight is considered to act. So just remember that actually every point has weight. All of the points of an object have got some weight. Every single point has got weight. But we pick the centre of gravity as being in the middle, and that is where we would mark the weight. So here, the centre of gravity, we're going to put somewhere in the middle of the man. So, the vertical distance between consecutive pictures increases, but the horizontal distance remains the same. So we can see that here. If we look at the centres of gravity of all of these pictures, which I'm marking in purple there, if we measure the vertical distance, up here it only moves a few millimetres, but down here it moves 4 centimetres. So the vertical distance increases, but the horizontal distance travelled remains the same. Explain this observation. Well, we can say that vertically, as it's getting bigger, it means the man is accelerating. He is accelerating. Why is he accelerating? Because there is a resultant force, his weight. Horizontally, there is no resultant force, so he moves at a constant speed, no acceleration. There is no resultant force, so no acceleration, constant velocity. Okay. By considering the vertical motion for pictures 2 to 10, show that the pictures are taken about 3 per second. So, what I need is I need to measure the distance on the picture and then work out the scale of the picture. So, just try to find a pencil. Pencil. So that I can mark on some distances here. So that's number 10. Here is this. So here we see that it's 9.5 centimetres. And they tell you that he's fallen 30 metres. So that is our scale. 9.5 centimetres is 30 metres. So the other thing we need to do is we need to work out the time taken for him to fall. Time taken to fall 30 metres, we're going to use a suvat. The S is 30, our U is 0, and our A is 9.81, and so we find the time. So we've got S is equal to UT plus a half AT squared. So we've got 30 is equal to 0 plus a half times 9.81 times t squared. So t is equal to 2 times 30 over 9.81 inside a square root. Just going to do that maths on my calculator. So the square root of 2 times 30 divided by 9.81, giving me a time of 2.47 seconds. So that is the total time to move from here to here. But we're after how much the time between each picture. So that means we've got 1, 2, 3, 4, 5, 6, 7, 8 gaps there. There are 8 pictures. There are 9 pictures, but there are 8 gaps. So it's actually 8 times that time has got to equal 2.47 seconds. So that means that the time between pictures is 2.47 divided by 8. 2.47 divided by 8 is 0.31 seconds per picture. So it says here a rate of 3 per second. So actually that means in 1 second, there's going to be n times 0.31. So n is equal to 1 over 0.31. 1 divided by my answer gives me 3.2 pictures per second, which is my answer. Okay. Sorry, 3.2 pictures per second is my answer. That's how many pictures in 1 second. Okay. Now the next question, it says the vertical height between the 2nd and 10th pictures is 30 metres. Take measurements from the photograph and use them to show that the horizontal distance between these pictures is between 12 metres and 15 metres. So we've already worked out my scale is 9.5 centimetres is 30 metres. That's the vertical scale. Now if we work out the horizontal scale, so actually I can change that into 1 centimetre is 30 over 9.5 metres. 30 divided by 9.5, 9.5 is 1 centimetre is 3.15 metres. So the scale of the picture vertically 30 metres is 9.5 centimetres. So 1 centimetre is 3.15 metres. That is my scale. Now I can work horizontally and I can measure the distance that he's fallen horizontally. So I've already drawn this line and I see that it's 4.5 centimetres. 4.5 centimetres horizontally. We've got 4.5 centimetres. So 4.5 times 3.15 is times 4.5 works out to be 14.2 metres. So that is our horizontal distance travelled is 14.2 metres. Calculate the horizontal velocity and the vertical velocity of the man for the 10th picture. Well, horizontally is easy because the velocity is constant. So we can just do that the velocity is the distance horizontally divided by the time. The distance is 14.2 and the time we worked out over here. This is the time taken to fall 30 metres was 2.47 seconds. 2.47. So that's 14.2 divided by 2.47, which is 5.75 metres per second is my horizontal velocity. Vertically I'm just going to use our CVAT equation. With u is equal to 0, a is equal to 9.81, and the time is 2.47. V is equal to u plus at, so that is 0 plus 9.81 times 2.47 to give me a vertical velocity, 9.81 times 2.47, of 3.9. Hang on, that's not right, is it? I did divide it by 9.81 times 2.47 to give me a vertical velocity of 24.2 and my vertical velocity of 5.75. Okay, so there is the answer to that question.